going to happen. All right. So consider the following sequence: figure 1, figure 2, figure 3. Remember how to do this? I think this is a very good problem to do. Yeah, Trish. No, come on, say it. No, all right. So, what is the algebraic expression for the number of elements of the nth figure? So figure number n, which doesn't look like a number, but it is.
N plus 2?
Not quite. So, remember, this is one of the few things I actually taught you how to do. So what you need to do is, all right, we've got 1, 2, 3, 4, 5. I don't know what that is. Onion rings? Onion rings, yeah, sounds nice. Somebody's hungry, I think. The other one has 7, and the other one has 9. Yeah? This is going to be so embarrassing for me because I always do this in Spanish in other places, and it's the first time I'm going to listen to myself speaking in English. So, all right, good enough. What's the difference? What's the difference? What's the difference? You have to add 2, and then you have to add 2 again. So you always add 2 to get the next one. That means it is going to be 2n plus or minus something. Yeah. If you are clever enough, you can realize that there is only one of the options with 2n.
You said.
But why 2n?
She's just asking a question.
You always add 2 and plus what?
Something. We have to figure it out. But the difference tells you the number that's multiplying the n. Right? It's always going to be a number multiplying n and then another number added or subtracted.
La cantidad de los números que avanza.
Es esa. Por n más algo. Okay. Yeah. So the only option can be 2n plus 3. All right. All right. It's all right. It's all right. Let's see. This is figure and this is a number. All right. Figure 1. You've got 5. Figure 2. You've got 7, right?
Yes.
Well, you can write that as 5 plus 2, right? Yes? Figure 3, you've got 9, which you can write as 7 plus 2, right? But that is also 5 plus 2 plus 2. Yeah? And that is also 5 plus 2 times 2.
Yes.
So the next one is going to have 11, which is 9 plus 2, which is also 5 plus 2 times 3, and so on. So you see, 2 times something arises naturally from there. But the first one isn't going to be just 2n or 2 times 1, because you see, the thing is, this is going to be 2 times 1, but that doesn't work. Because 2 times 1 is just 2, and we've got 5. So what is it that we need to add? 3, I guess. So the formula here is 2n plus 3. So that's how we get what do we need to get. Alrighty. Hello, how are you? This is your teacher. Alrighty, problem 1. This is a problem that is so simple, and yet it confuses everybody once in their lifetime. Machine 1, you've got 2 machines. The machine 1, quadruple of the input. So we can say something like this. This is 4 times the input. Machine 2, the input lowered by 7. So it is the input. What does it do to it? What does subtraction? Yes, lowering means to subtract. Yeah. The algebraic expression m, all right, m is going to enter the first machine, so it's going to be the input. And the output of that machine is the input for the second machine. What is the output at the end? So m comes in as the input of the first machine. What is going to be the output of that machine if it quadruples? Exactly. This is going to be 4m. 4m, right? M enters, 4m exits. And then that's the input for the second machine. So the exit is going to be, the output is going to be 4m minus 7, which happens to be, as Tricia said, C. All right? All right? Yes? Yes? Everybody all right? Everybody happy? Yeah. Good. Let's move on to the second one. The price of a product in a store is N. All right? The price is N. But we are going to apply a 20% discount. Yeah? There are many questions that could be asked with that setup, all right? So you have to be very careful about the question that actually is there. What algebraic expression represents the value of the discount applied to the product? What algebraic expression represents the value of the discount applied to the product? Yeah, exactly. They could have asked something else. For instance, what is the final price of the product? And that would have been 0.66 N. So you have to be very careful when reading this question, because the question changes everything. No, the answer is what you said, A, 0.24, because the question is about the discount, and the discount is 24%.
And the final price is?
The final price is the rest. So what's the difference between 100 and 24? 76. Alrighty, so this one is very, very simple, but it's still valuable to. And I go into my speaker voice, like, hello, I have a very deep voice. I'm sorry, I'm so nervous. Pablo is a good worker. He must fix. All right, there is a long story. No, it's not a good packer. It's a good worker. It's a long story. But the thing is, they give you the equation. So if we jump to the question is, in the equation, what does the expression 2x plus 8 represent?
All right? Things that he used for the second door.
I don't know. I have to read the story. So let's read the story. He has to fix 3 doors in a house. He used 38 screws. For the second door, he used double the number of screws he used in the first one. For the third door, he used 8 more than the number he used for the second one. All right? So, first door.
Yeah, double. Those, 4.
Second door.
36.
Third door. Read the question. All right. The variable x, they say, represents the number of screws used in the first door. So, in the first door, he used x. They told you, for the second door, he used double the number of screws. So, what is double x? Double x. If you say something coherent, you can do that. While he used 8 more for the third than the second. So 2x plus 8. And the question is, what does the expression 2x plus 8 represent? And now we know. It's the number of screws he used for the third door. So there you go. Easy? Yeah. But you have to read the question. And it is a good idea, it is a very good idea to do something like that. So kind of ordering the story, arranging things to put them in order. right?
Okay.
Alrighty. So this one, number 10, we did already. It is in the book. Diego is 6 years older than his brother Joaquin. So we did it. I'm going to skip it. We can safely skip it, all right? But I want you to take a look at this one. This is also a very, very important kind of problem, if you know what I mean. I shouldn't say that. I'm going to edit it. Problem 11. Luis sells reams of letter paper, legal paper. Resmas. Resmas. Las cajitas de papel. Los paquetitos. Que vienen 500 hojas. 500 hojas una resma de papel. The number of letter paper reams he has in stock is 5 more than double the number of legal paper reams in stock. He has 47 reams in stock, both legal and letter-sized. How many letter paper reams has Luis got in stock? All right. I can't understand it. So we have to go through this very carefully, right? All right. Look, if you read the problem well, you can realize that there are two things: the number of letter paper reams and the number of legal paper reams. Yeah? So,
There's a number of legal paper.
letter paper, and legal. Yes, those two things are the ones we are interested in. All right. One of them has to be X, but which one? There is always, in this kind of problem, you go back to one of the variables. You go back to one of the variables. You're referring back to one of the variables. And the variable you're going back to is going to be X, because that's the simplest way to do that. You can do it in other ways, but the simplest one is to name X the variable you're going back to, you're referring back to. So let's see. The number of letter paper reams he has in stock is 5 more than double the number of legal paper reams. So the number of letter paper reams depends on the number of legal paper reams. So legal is X. Yeah? And let's see how many letter paper reams are there. Is 5 more? What does 5 more means? We have to add 5, right? 5 more than what? No, read that. Double the number 2x. So now we've set it up. Now we set the equation up. But we also know, no, we haven't set the equation up, actually. Because there is one last piece of information, which is he has 47 reams in stock. Both legal and letter paper. Yeah? So it means that 2x plus 5 letter paper plus legal paper reams, in total there are 47 of them. And we've set the equation up, and now we can solve it. All right? So let's solve it. 2x and x make 3x plus 5 equals 47. 47 minus 5, 42?
Yes.
I'm getting better at this. And what is 42 divided by 3? I cannot do that for the life of me. 14? Oh, you're so fast. 14, is it right? Is it right? Can we check? Yes, it's right, I think. All right. So, but question, what is 14? The number of legal paper reams. Because this is X. So this is legal, yeah. Actually, no, but kind of. And the question is about letter paper reams.
33.
Yeah, so letter paper reams are 2 times 14 plus 5. because x is 14, and that's legal paper reams. 28 plus 5, this is your 33. So the answer is 33 reams of legal paper. Yay, another one. So, number 12. Luis uses his money to buy a TV set, a bike, and a computer. He paid 85,000 pesos more for the TV set than for the bike, while he paid 10,000 pesos less for the computer than for the TV set. He spent 595,000 pesos in total. How much did he pay for the computer? We have to set this equation up. We have to set this up. So, it's always a good idea to read the question and try to name that as x, but it may not work. So, another trick you can do is, who refers back to whom? If you ask that question, it's going to solve it for you. So, let's see. The TV set refers back to the bike, right? So kind of the TV set depends on the bike. And then the computer depends on the TV set. But the TV set depends on the bike. Yes? So it's something like this. TV depends on the bike, and the computer depends on the telly. Yeah? So everything goes back to the bike. So that means it is a very good idea to name the price of the bike as X. So X is the price of the bike. All right. So we've got the bike, the price of it, and that's X. Then we have the telly. What happens to it? He paid 85,000 more for the telly than the bike. So X plus 85,000. And then we have the computer.
X minus.
Let's see. He paid 10,000 pesos less for the computer than for the telly. So he paid this for the telly, and then he paid 10,000 pesos less. Yes? Now we can solve that very easily, because 85,000 minus 10,000 happens to be 75. I have to erase everything because things happen. So they told us he spent 595,000 in total. So it may be a good idea to add everything up, because they're asking us for a total, right? And total means adding. So what is X and X and X? What is 85 and 75? A lot. I don't know. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 0 is 0. 5 and 5 is 10. 8 and 16, right? Hey, come on. I haven't done this in years. Yes, I know. ¿Está bien sumado?
Parece.
Yeah. Entonces, 3x plus 160,000 equals 595,000. So what should we do? We have to do what we have to do, right? This 160 is adding, so we subtract it. What is 595,000 minus 160? Thank you. And now we have to divide by 3. So what is that divided by 3? 100? 45? Yeah, so the answer is A, right? No. Because what is X? The price of the bike. And what did they ask you for? The price of the computer. So the price of the computer is 145 plus 75. So 220,000, if I'm not mistaken. That's it. That's it. That's it. Let's do the next one.
Es que a nosotros nos faltó poner, o sea, solo lo dividíamos por 2x en vez de eso. Olvidamos la x de la bike y solo
Yeah.
pusimos de los
No, 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 no. Let's do this one. A courier sends parcels to 3 different regions, Tarapacá, Biobío, and Los Lagos. 1 month, the number of parcels sent to Tarapacá was double the number of parcels to the Biobío region, and the number of parcels to Los Lagos was 12 more than those to Tarapacá. So, again, the same idea. We have to refer back to something. So, Tarapacá refers back to Biobío, right?
Yes.
And Los Lagos refers to Tarapacá, which in turn refers back to Biobío. So Biobío should be X. And then Tarapacá is double the number of 2x. And then we have Los Lagos, which is 12 more than those two Tarapacá. Tarapacá is 2x, and 12 more is plus 12. As a whole, 182 parcels were sent. What does it mean? In total, right? As a whole. So how many parcels were sent? X and 2x and 2x make 5x plus 12. So 5x plus 12 must equal 182.
Yes.
And 5x therefore must equal 170. And x
34.
34. Thank you. Now, this is the number of parcels sent to Biobío, because Biobío is x. And the question was about Los Lagos. So, Los Lagos is 2x, 2 times 34,
80.
plus 12. Is it 80? Well, I'm going to believe you. You tend to be right. So the answer is D. The last one I gave you to solve on your own. Pedro owns an undetermined amount of money. From that amount, he spent 40,000 pesos. And after that, he spent 5/8 of what remained. If X is the initial amount of money, what is the algebraic expression for the final amount of money?
La.
Not quite. All right, come back. Quedar. Lo que queda. Lo que se mantiene también es otra forma un poco más ansiótica de decirlo. No voy a borrar de la grabación. Camilo, I know it's hard for you, but shut up. All right. X is the initial amount of money. Yeah? And then he spent 40,000. Spending 40,000. Now, this is the important part. He's going to spend, all right, so minus, right? 5/8. All right, 5/8. Of, this is the important part. Of what? Of what remained. And what is remaining? He had X. He spent 40,000. What is remaining? X minus 40,000. This is what remains. Because X is the initial amount, and then he spent some money out of it. So x minus 40,000. But is that all right?
Brackets.
Yes, we need brackets because we are multiplying something which is one thing conceptually. And there it goes. That's it. Very easy, very simple. So the answer is C. So we're back. Problem 23. What is the algebraic expression for the gray area? Now the thing is, this isn't hard. But shut up. But you have to think about it. This isn't hard, but you have to think about it. Now, any ideas on how to get the gray area there? That's a good idea. That may work. Any other ideas?
Look.
Shut up. All right. I think we can do something like this. We have a square, right? The big thing here is a square, which I'm drawing terribly. That is a square. But this is also a square.
Yes.
So the gray area is the difference between the area of the blue square and the green square. Yeah? So what if we get the area of the big square and the little square and then subtract them? Yes, I know. Sorry. I'm an idiot. But you know that. So, big square. What is the area of the big square? A plus B times
2 times
A plus B.
times 4.
base and height. A plus B times A plus B. Alright? That is the area of the big square. The blue square. So, wait. We have to multiply this, right?
Yes.
So what is the multiplication of that?
Those are más.
No. A times A squared.
A square más B square.
AB
Plus AB
plus another AB
plus A
plus B squared. Can we simplify that?
Yes.
How? 2AB. So the area of the big square is A squared plus 2AB plus B squared. Now, what about the little square? B times B, right?
Yes.
Just B times B, which happens to be B squared. So the gray area is the big square, A squared plus 2AB plus B squared minus the little square
B
minus B squared. So no, there's no need. You're not mixing multiplications and subtractions or additions. So what is that?
binomio por algo así.
A squared plus 2AB. And the answer is
Sí.
C. Yes? Is it clear? Clear enough? No, what happened? So the area of the big square is that. The area of the little square is that. And you want to get the difference. Yeah, so that's that. No, I'm not going to erase it, but I'm going to pull.
Es algo
So
que-
let's now do this one, 25. What is the algebraic expression for the area of the gray triangle? So, do you remember the area of a triangle?
Yes.
Yes, base, height, divided by 2, right? So, what is the base of this
A
triangle?
plus B.
8 plus b. What is the height?
3B.
3b, right? But we have to divide it by 2.
Yeah.
So that is the area. So, what can we do? What is 8 times 3b? 8 times 3 equals 24.
Yes.
So 24b. What is b times 3b?
12, what?
No, b times 3b.
B times 3B.
3b squared. You're confusing with additions.
Yes.
And this is divided by 2. Now, if you look at the alternatives, none of them is exactly that. Can we do something? Yes, we can. Now, I have to tell you this. Fractions, well, this is going to my own YouTube channel, so I can say whatever I want. Fractions are a bitch. All right? You know that already. So, the thing is, fractions and additions and all subtractions, which are the same, have a complicated relationship. They have a complicated relationship. Pay attention to this, because this is important. If you have something like this, where you have an addition or a subtraction on top, on the numerator, that is not a problem. That is quite all right. You can separate these into two fractions. If you have an addition or subtraction here, down here in the denominator, you cannot separate that. Right? You can separate into many fractions when you have additions on top, but not on the bottom. Not on the bottom. Alright? So, we can separate this one because it has one addition on top. How do we do that? Well, this is going to be 24b halves plus 3b squared halves. 24 divided by 2? 12b plus 3b squared half. Is that any of our alternatives? Yes, it's alternative D. So, in a different order, but it doesn't hurt. So that's the solution we're looking for. Yeah? I want to do one last problem before we leave.
Okay.
Wait, you're going to have it anyway. So I want to do one last problem, or two, or three, maybe three.
One.
You all had trouble remembering what a ratio is
Yes.
during your last workshop, so let's do this too. Problem 31. What is the ratio between the perimeter of the equilateral triangle and the perimeter of the square? What is the perimeter? Yeah, the sides, right? The sum of the sides. Now, you have to, it's, sometimes you're going to use the perimeter, but it's not going to say use the perimeter. For instance, one typical example is fencing. When they ask you, all right, you want to fence this plot of land, well, a fence goes along the perimeter. Right? So the length of the fence is the perimeter of the plot of land. So, what is the perimeter of a triangle?
A más A.
Yes, and that happens to be 3A. Triangle, dear. 3A. What is the perimeter of the square? 4A. 4A. Sounds like 4A. Sorry, that jokes. Ratio. We're comparing between what? Triangle and the square. Remember, the order is important. They told us triangle and then square. So 3A. Oh, I almost said a forbidden word. 3A to 4A. 3A to 4A. Question, because that is not one of the answers, right? Can you simplify this? Yes, of course you can, because a ratio works a bit like a fraction. So you can simplify by A. And this becomes 3 to 4. And that is one of the answers. C. Let's do 32. You don't have to do anything to solve this.
Why?
You don't have to do anything to solve this. Wait a minute. Don't leave yet. What is the ratio between the area of the triangle and the area of the rectangle shown in the figure? How many times does the triangle fit inside the rectangle?
2.
2 times. Yeah, 2 times, one here and one here. One here and one here. So what is the ratio? The triangle is 1 and the rectangle contains 2. So the ratio is 1 to 2. Now, if you don't see that, which is perfectly valid, how do you solve this? Well, what is the area of the triangle? The area of the triangle is 3b base times height a divided by 2. So this is the triangle. And what about the square? 3b times a. And that is the ratio, right? Can you simplify things? Yes, of course you can. 3 with this, b and b, a and a. And what are you left with? You have 1/2 to 2 to 1. Now, that is not one of the alternatives, so we can multiply by 2. And this becomes 1 to 2. So yet again, the answer is 1 to 2. Alright, this is truly the last one. Truly the last one. So,
Really?
yeah, I mean it this time.
Do I have to believe you?
No, you don't.
Yes, I don't.
But it's good for your health. Consider the square in the figure of side x. What is the algebraic expression for the gray area? All right, this one is a little harder. Just a little. A tad. Question. All right, so we want to know the area of the gray rectangle. To know the area of a rectangle, we need to know the length of the base, or the length, just the length, and the width, right? So question. Yeah, what is this length? The base. Yeah, X menos A.
Menos A eso.
Because all of that was X, and we took A from it.
Yeah.
And what is this length? Yeah. The whole length was X, and we took B from it.
Yeah.
So what is the area? It's going to be X minus A times X minus B. Is that all right?
Yes.
No. Brackets.
Brackets. Yes.
Because you're multiplying things, which conceptually are one thing. Now, can you multiply that? All right, let's do it. X squared, right?
Yes.
And then minus B, X times minus B. And then minus A times X is minus AX. Minus A times minus B, what is that?
Plus AB.
Great. Now, that is not one of our alternatives, directly at least. Can we factor that minus bx and minus ax? What do they have in common?
Yes.
Something else?
Minus X.
Minus x. They have in common the minus sign and the x. And what are we left with? Well, with an a and a b, we took out the minus sign. So what sign remains there? A plus sign. And we didn't do anything to the plus AB, right? So it stays the same. And that is alternative D, I believe. Yeah? So we factor that, we factor it, and we factor it by x, but also by the minus sign. We take out the minus sign. So with that, we're finished, we're done. Have a great weekend. See you next Tuesday. for the test. I'm going to be on time. You have to be on time too. Everybody is going to be on time. I'm going to send you this very soon.
It doesn't